So the goal of this video is to provide a brief introduction to chemistry, and that's because we have to understand chemistry to set the stage for a proper understanding of biology at the molecular level. So in this video, we're going to discuss the basics of elements and atoms, and we're going to talk about atomic structure and atomic symbols. By the end of this video, you should be able to name and define the parts of an atom, as well as use and analyze atomic symbols. So to begin, we're going to discuss a few important terms. So first, matter. All living things are composed of matter, which can be defined as any substance that has mass and takes up space. All matter is composed of elements, and elements are substances that can't be broken down into simpler substances by ordinary chemical reactions. Elements are then composed of atoms, and an atom is the smallest unit that retains all of the chemical and physical properties of that element. So to put this in terms that you're a little more familiar with, here we see some of the elements that make up seawater, humans, pumpkins, as well as the Earth's crust. You can see that seawater is mostly composed of oxygen and hydrogen, 88% oxygen and 11% hydrogen, which makes sense because water has the chemical formula H2O composed of hydrogen and oxygen. In contrast, if we look at a human, we can see that the most common four elements shown here in red are oxygen, carbon, hydrogen, and nitrogen. This is very similar to a pumpkin, which also has a great deal of oxygen, hydrogen, and carbon, although it has less nitrogen. In contrast, the Earth's crust, while it has a lot of oxygen, the second two most common elements are silicon and aluminum. You also see here that I've labeled some of these elements in blue. These are elements that are found at very, very low levels in living things. So you can see here that iron makes up only 0.4%, while iodine makes up only 0.04% of the mass of a human. These are referred to as trace elements because they're present at very low levels. However, that's not to say that trace elements are not very important. So in the abs, for example, deficiency in iodine can cause a swelling of the thyroid gland known as goiter. You can see here a man that has a goiter. And in order to combat this, now iodine is added to most of our salt, and the prevalence of goiter has decreased significantly. Similarly, iron deficiency results in a disorder called anemia, in which we have decreased transport of oxygen by the red blood cells. And that's because iron is very important in binding of oxygen to the molecule hemoglobin, which is how oxygen is carried by our red blood cells. So let's get back to those important terms. So as I remind you, an atom is the smallest unit that retains all of the chemical and physical properties of an element. So in order to understand how elements function, we need to understand a little more about the structure of an atom. So here we see an atom, and first let's look to the center in the nucleus. The nucleus is made up of protons, which carry a positive charge, and neutrons, which carry no charge. The number of protons is very important because this is what defines the identity of an element. So different numbers of protons are associated with different elements. In contrast, neutrons determine the isotope of an element. So atoms of the same element with different numbers of neutrons are referred to as isotopes. So then surrounding the atom, or surrounding the nucleus, we have here shown in yellow, we have the electrons. So the electrons carry a negative charge and they orbit around the nucleus, forming a negative cloud. This will be the focus of most of our lecture in class because these electrons are what determine the chemical behavior and the bonding properties of an atom. So to understand this a little bit further, we represent these numbers of protons and numbers of neutrons via the atomic symbol. So here we have the atomic symbol for oxygen. You see here we have a large O with a superscripted 16 and a subscripted 8. So first, let's begin with that large O. This letter is the atomic symbol for oxygen, shown here, this O. And you can see here that, looking at this periodic table, that different elements have different symbols associated with that element. Many times it is the first letter of the element itself, but that's not always true. For example, you can see here that iron is represented by the symbol Fe. So next, we have the subscripted 8. And if we zoom in on the periodic table, this is what represents the atomic number. And we can see it here in the top left-hand corner of the box, and each element has a different atomic number. And that's because the atomic number represents the number of protons. And as you remember, the number of protons is ultimately what defines the identity of the element. So here, the superscripted 16 represents the atomic mass. The atomic mass is the number of protons plus the number of neutrons, also known as the mass number. It's called the atomic mass because if you remember, the atom is made up primarily of protons and neutrons, that's the nucleus, and that number of protons and neutrons together makes up the majority of the mass because electrons are very, very light, weighing only approximately 1/1800th of the mass of a proton. So hence the name atomic mass. So this is also present on the periodic table, but you'll notice here that it says that the atomic mass of oxygen is 15.9994. That's because the number shown on the periodic table is a composite of all of the isotopes of that element that are present in the Earth. So here you can see that probably most of the isotopes of oxygen that are present have an atomic mass of 16, but some of them may have an atomic mass of 15 to make that average a little bit lower. And this is another example of several isotopes. These are all isotopes of carbon, and we know that because each one has an atomic number of 6, representing 6 protons. However, they have different numbers of neutrons. This one has 6 neutrons, the center one has 7 neutrons, and the one on the right has 8 neutrons, so yielding an atomic mass or a mass number of 12, 13, and 14. And isotopes can be very important because some isotopes, such as C13, can be radioactive, and these are specific isotopes that are unstable and can decay into other elements. So that's the end of this video, and watch it over again as you need, and we'll begin class by having a couple of examples of problems that apply the knowledge that you've learned from this video.